So I want you to try one, right? So I want you to try one on here, okay? And so this is what I want you to try. And so example number 4, I think. So f of x is your arctangent x. So what is the derivative of arctangent x? It's 1 over x squared plus 1, or 1 plus x squared, right? So let me write it as 1 plus x squared. And this was problem number 1, right? So this is the first problem we did today. So now you want to integrate that and get to this part. So see if you can figure this one out, right? So we already did the first part, right? So this was problem number 1, right? So this is problem 1. So we already did that one, right? So see if you can actually integrate it and get your answer. So let me pause the recording, erase everything here, and write it out a little bit nicer. And so we have a negative 1 to the n plus 1, an x minus pi to the 2n power, all over a 2n factorial. And that is our power series. Questions? So I want you to try one. So I want you to try this again, okay? So I want you to try exactly the same thing, cosine x, but the center is at pi over 2 instead of pi, okay? So let me go ahead and write it over here. Okay, so I think this is example number 7. So our f of x is equal to cosine x, where the center is pi over 2. Okay, so again, the first steps is making a list of your functions and its derivative, which we already did, right? So we already had that a while ago. So it's cosine x, f prime is negative sine x, f double prime is negative cosine x, f triple prime is sine x, right? And then the fourth derivative is cosine, so it just repeats now. Now this time you are plugging in a equals pi over 2. Oops. All right, so now if I plug in pi over 2 for cosine, what do you get? 0, right? For negative sine, you get what? Negative 1, right? And then this one again is 0 because it's cosine. Positive sine x would give me what? Positive 1, right? And then 0, and so on and so forth. So again, I usually don't write the 0 terms anymore, right? So if you don't want to, you don't really have to. Now remember, the order of your derivative matches the power of your power series term. And so this is now what we have, okay? So there's no constant, right? So there's no 0 power. I have a first derivative. So that would be negative 1 x minus pi over 2 over 1 factorial. And then plus, there's no second power because it's 0. There is a third one, so it would be a positive 1, x minus pi over 2 to the third power over 3 factorial. There's no fourth power, so if I am going to guess, the next one would be a negative 1 to the x minus pi over 2 to the fifth power over 5 factorial. Again, it alternates signs, right? So negative 1, positive 1, negative 1, positive 1. And so now, as a power series, n equals 0 to infinity, it's going to have another negative 1 to the n plus 1 power, right? Because you want it to start as a negative. So my power series is now x minus pi over 2. So what should be my exponent? It can't be n because it's not in sequence, right? So it's not in sequence kind of power, unlike your e. So what should be the power for x minus pi over 2? Anyone? Close, but the problem with n plus 1 is if n happens to be 3, 3 plus 1 is 4, and notice there's no 4 on here, so it can't be n plus 1. So first, the powers has to be odd, right? Because it's 1, 3, 5. Does anyone know how to get an odd number using n? Does anyone know? Okay. So if no one knows, okay. So remember, for even, it's 2n. So 2n is even. How do you make that odd? So if 2n gives me an even number, how do you make that an odd number? Plus 1. There you go. So an even or an odd power is 2n plus 1. An even power is 2n, right? So then that means this is 2n plus 1 factorial. And there is your power series, or in this case, Taylor series for cosine x centered at pi over 2. Any questions on that? Any questions on it? Now, usually the question that's asked often is, how far do I go for the derivatives, right? So I know we're going up to the fourth. So how far do we go as far as your derivatives are concerned? Well, enough so that you can actually figure out the pattern. So you need enough if there is to figure out the pattern. So over here, I probably should have gotten one more so that I actually have quite a few terms that are not 0. So you need enough derivatives so that you can figure out the pattern when you write out your summation notation. Okay. Any questions on that? Because I think it's time for a break. So I want to take a 10-minute break right now. Okay. So let me pause the recording. Okay. All right. So I want to make sure I pretty much ask everything that you'll see um, on your homework. Okay, and so usually what it's already mentioned, what you're going to ask or what you'll be asked is what you typically ask is how far to go. Now, on your homework, on some of your homeworks, it tells you to stop to a specific power. So meaning, they say, oh, it's you stop at the third degree term. So you're going to stop at x cubed. So which means you're just going to stop right there, and then that will be it. The other thing is it will say Maclaurin series. So if it says Maclaurin series, automatically the center is going to be 0. Okay, and so they don't have to tell you the center. You're supposed to know the center happens to be 0. So I want you to try that for me. Okay, and so example number 8. Okay, so find the Maclaurin series for f of x equals sine x. Okay. So you're basically going to do exactly the same thing we just did, obviously for sine, but now you're going to plug in 0 as your center, right? So how do you know it's 0? Because it says Maclaurin series, right? So it's automatically a center of 0. Okay, so go ahead and do this for me. Okay, so again, let's make a list, right? So f of x is sine x. F prime is cosine x. F double prime is negative sine x. F triple prime is negative cosine. And I just need enough, right, that I will not get too many zeros. And since I am going to plug in 0 for x, the sine ones are going to be 0. So that means I need a few more here. So the fourth derivative is sine, and the fifth derivative is going to be cosine. And then I plug in 0. So this would give me 0. This would give me 1. This would give me 0. This would give me negative 1. This would give me 0. And this would give me positive 1. So my sine x so far would be, right? So there's no constant because that's the regular function value. It's 0. The first derivative is 1, so it would be 1 over 1 factorial. And since it is a Maclaurin, it is just simply x to the 1 power. Okay. No second derivative, right? And then there's a third one. It's negative though. So it's negative 1 over 3 factorial x cubed. No fourth, right? So the fourth again is 0. The fifth one is a positive 1 over 4 factorial x to the fourth, and so on and so forth. And so the power series, or the Maclaurin series, n equals 0 to infinity, it would be x to the, again, odd power. Sorry, this is fifth power. I messed this one up. This is the fifth power. So this is to the fifth. This is 5 factorial. So it's going to be 2n plus 1 over 2n plus 1 factorial. And then you have negative 1 to the n power. It starts positive this time, so it's just n power. And that would be your Maclaurin series. Questions on this? Any questions on it? Okay. All right, and so I don't want to go through having to do this for all, or at least most of our functions. So I want to write down some sort of commonly used Maclaurin series, right? So, so let me flip this over, okay? And sort of, because I want to make a table. So these are common results of Maclaurin series. Okay. The first one, the 1 over 1 plus x, right? It is um, a power series centered at 0, and we already saw the answer to this one, right? So this one was 1 plus x squared plus x cubed plus dot dot dot. So as far as power series are concerned, that would be from n equals 0 to infinity.